So today I'll be talking about service mesh and how Containous, the creators of Traefik, have managed to untangle the mesh by thinking outside the net. Now before we get started, allow me to introduce myself and Containous. So my name is Kevin Crawley and I am a developer advocate for Containous, and I started in April of this year, 2020. And I'm a software engineer by trade. I've been working with application development in some way, shape, or form for about 30 years. And I started with BASIC about when I was around 8 years old. And more recently, I've been mostly working in Java and Go. I've been working with distributed applications of some sort for around, I think, 10 years now. And I'm also engaged with my community. I am an organizer for DevOps Days Nashville, and I'm also an organizer for the Docker Nashville meetup group and the Go meetup group here. So who is Containous? Well, we were founded on open source principles, and we're the creators and maintainers of Traefik, Mesh, and Yegi. And we also offer Traefik EE as a commercially supported version of Traefik. That includes additional security features and high availability features that aren't available in the regular version of Traefik or Community Edition. And we have around 30 incredible people across the globe. We're all over the place. And myself, I'm in Nashville, Tennessee. So before we can talk a little bit about service mesh, let's cover the topic of kube-proxy and what it does in Kubernetes. That provides a basic load balancer across a pool of IPs using IP tables. And what that does is it ensures service-to-service communication, and that it works once a service is resolved by the internal DNS handler, which is typically kubedns. This is a round-robin load balancer, and it's not very configurable. So the service mesh, it exists to either extend or in many cases outright replace kube-proxy, and it does that to expose additional features. And we're going to talk more about those on the next slide, but those features can be managed through the Kubernetes API and objects, YAML. And this configuration typically exposes traffic management and security features and functionality. So why would we want to use something like that? What are the benefits? Well, it's abstraction, and it adds additional functionality to service or east-west communication, such as advanced routing. And it includes traffic splitting with weight, so it sends more traffic to one service versus another. And it has the ability to incorporate access controls into those policies, which will limit which services can access those specific endpoints or routes. It also handles implementation of mutual TLS encryption and authentication between those services. It also handles advanced management of traffic, such as retries, backoffs, and circuit breakers. And what this does is it allows the operators of those applications that run in the mesh to manage these capabilities at the provider layer rather than at the application layer. And at the application layer, it can be really hard to maintain, especially if your services are polyglot and you're distributed globally and you have many different teams working together in the same application. So this also allows for a centralized emitter of the metrics and the traces that represent the above behaviors. And we'll touch on that a little bit in the demo. So when we set out to create this a service mesh, we wanted to overcome some challenges. So many users were reporting that the implementation of service meshes were often difficult to configure and manage, and they had also been considered a significant resource overhead. Now, in some cases, this could be an implementation problem or a use case issue, and there's a lot of considerations that you have to make when implementing a service mesh, and one of those includes accepting some performance and overhead trade-offs when you want to use the features inherent in the solution. Now, we also wanted to bring about a solution that was really not that invasive. It was simple, and we could trade it out with any other solution without a significant amount of effort. And we also wanted it to offer our users a lot of flexibility with how they use the network. So we knew what our challenges were, and it felt like a pretty big list of problems to solve. So how did we do it? Well, the first was we really needed to look at the problem the service mesh was solving. And in reality, a service mesh is just another proxy or a collection of proxies. But typically, those proxies have a lot less features baked in a full-size proxy. And those features are specific to those mesh use cases that I discussed earlier. Say that 10 times fast. Now, we thought we might be able to leverage our existing open source proxy software, Traefik. Some of you might have heard of it. The reasons we wanted to go that route were pretty obvious. It's actively maintained, it's secure, and it's feature rich, and it has the majority of the functionality that we needed already for a service mesh. And the development towards the service mesh would enhance Traefik and vice versa. Now, on the other hand, throwing a full-sized proxy into a sidecar on every single pod would have resulted in the Traefik gopher literally and figuratively being run over. So should we just fork it and adapt some of the existing middleware for service mesh? Well, let's find out. First, let's take a look at what the Traefik topology on Istio looks like. You can see here that every single one of these pods has a proxy installed, and the rules are propagated to every single one of those pods. It's an all or nothing type approach, and it's specifically what we did not want to do with our solution, because ultimately we didn't want everybody to get a sidecar proxy. So what did we do with Traefik and mesh? So we set it up so there was a single proxy per node. The rules are propagated to only one proxy, and it's opt-in behavior. As you can see here, communication between pod 7 and 8 still happen, but we also have mesh in there so that we can communicate through the service mesh and get some of those benefits of it. So let's get to know mesh. So we ended up going with Traefik, as you can probably tell, because we found a way around the every pod gets a sidecar approach. Now, because of this and how we architected this solution, it becomes relatively lightweight and minimally invasive. And as a result of that, the opt-in behavior becomes as easy as a new domain name record, making that opt-in quite optional and very transparent. You're going to know when you're addressing the service mesh because you literally have to adjust your DNS. So as a result of that, and in addition, we implemented the SMI spec, which I'll cover more about what that is and how it works in depth here in a moment. So out-of-the-box features that come with mesh, I covered most of these during the intro, so I'm not going to go over them again. But because of Traefik, the amount of work required to implement these features was really minimal. We're essentially putting a small shim in front of the Traefik software and committing some of the features needed to accomplish this upstream to Traefik as well. So what is SMI, or Service Mesh Interface? Now, this was originally created by Dice Labs, who were acquired by Microsoft, and they've continued the work. But the goal of the project was to provide an abstraction to the configuration of some very common use cases in service meshes. So let's go over a few of those. First one, in this example, we're going to talk about access controls. Now, before we can do the access control, we have to define some resources, or our routes. And you can see some fairly common verbs in use here, and it's relatively straightforward, but it enables us to create groups of resources that we'll use later to define which services can access them and where those rules actually apply. Now, in this example, we're configuring the API service metrics endpoint to only be accessible by services that have the Prometheus service account attached to it. And in this example, you can see that we're assigning services that have permission to the API itself, which means those services would not be able to access the metrics endpoint on the API service, only the /API route. Now, we can also configure the HTTP route group against any number of different options rather than just routes or methods. We can inspect cookies, user agents, headers, etc. Now, this becomes really powerful when we want to route traffic based on specific users, technology, or metadata. And we can be using this for things such as A/B testing or canary testing. So let's consider the configuration we're looking at here. We've targeted Android users, and we're looking for a cookie, which probably indicates the user is an insider. Perhaps they've opted into testing for us, and we're going to use this here in a moment. Now, before we can do any type of testing, we have to define how we're going to route that traffic to our canaries, essentially. And what we've configured here is a traffic split, in essence. And that's going to supplement the routing for the targeted services, in this case, website. And it's going to route based on those weights to those version backends. And we'll cover this in the demo. And here we've actually taken that same rule, that traffic split rule that we just created, and we've applied the HTTP route group that I just talked about so that we can target the users who are using Android and who have opted in. So let's get started with our demo. Now, this demo is pre-recorded, so if it doesn't work, you'll probably never know. So today I'll be demonstrating how the service mesh proxy works through a demonstration of canary testing of east-west traffic. That's internal service communication. This isn't going to include any type of ingress routing for canary testing. I'm also going to demonstrate how the standard routing will work alongside the mesh routing, and I'll use some tools like Grafana and Jaeger to illustrate how this works. So let's go ahead and get started. Now, what I do need to do is deploy mesh, and that's just a simple Helm install command, and that's going to take about 30 seconds to install. And while that's happening, what I will do is show you a little bit how the templating works for the application. So within the application itself, we've configured our endpoints. One of them uses the mesh routing by appending .local.mesh, and this can be configured as well. And also you can see here that the visit service is not using that, and what that will do is that will tell that traffic to go through the kube-proxy. So by now, we should be up and going. So the demonstration app is called Spring Pet Clinic, and it's a microservices version of the application. It includes a number of different CRUD type actions. You can create records, you can update them, you can delete them, and it all flows through like 6 or 7 different microservices. So it's a pretty lightweight microservice example, but it's not as big as one might be in real production, but also it's not just one service. So it kind of shows you a little bit of how some of the topology might look like in a larger application. So now that that has been deployed, I want to start some load testing on my project. So let's go ahead and kick that off. And that will just generate some traffic within our application so that we can see things happening. And I'm going to deploy the version 1 and 2 of our application so that we have a canary to work against. So I'm just going to deploy version 2 and then deploy version 1, and those should start running momentarily. And we can see here that the application is being deployed to our Kubernetes cluster. Now, if we go over to Jaeger, and we see here that we have customer service, but no version 1 and 2. But if I go ahead and refresh this, within a few moments, it'll start populating version 1 and version 2 as the services are deployed, and Jaeger discovers those. So you can see here that version 2 showed up. But if we start looking at the traces for it, we're going to notice that there's no traffic being routed to it, and that's normal because the service doesn't have any kind of routes to it yet. So once we see that the services are up and running, we can go ahead and deploy the traffic split, and that is this file here, and that just defines the split on that route so that 75% of the traffic goes to V1, 25% goes to V2. So let's go ahead and deploy that. All right, and we should start seeing some traffic here momentarily. Oh, okay, I forgot that was there. All right, so now we can see traffic starting to flow through here, and we can see traffic coming into V2 as well. And we see here that there's one query that actually goes to the non-mesh route, and we can see the traffic that is actually going to the mesh route here. And we see customer service local mesh, and we see our system picking that up and forwarding the traffic, and that traffic going to the right place. And so, as illustrated, we have effectively canaried our internal service. So that's it for the demo. Let's go ahead and wrap things up. All right, so let's talk a little bit about what we talked about today and some on the future of mesh. So we covered how we were able to offer a lightweight service mesh alternative with mesh and how we accomplished that using Traefik and the topology and architecture of it. And we also talked a little bit about how we supported the emerging standards that are being developed by the SMI community, but we're also involved with maturing the features available using SMI. And more recently, we were involved in developing the standards around UDP and support for that within the SMI working implementation. And on top of that, we are planning on doing further enhancements, and we need your help with that. And that includes adding additional SMI specs, including metrics, making sure that we stay up to date with the implementation of SMI, as well as encryption, such as MTLS. So how can you get involved? Well, first, I'm happy to announce that we are doing a $50 Amazon gift card giveaway for the people who are attending this talk live. And you can enter that giveaway by signing up for a monthly newsletter. And that includes a summary of the community activity around Traefik and mesh, which includes things like blog posts, videos, tutorials, and upcoming talks. And if you're watching this talk live, I will create a link to that in the chat so that you don't have to enter it right this minute, but within the next hour or so, you should enter if you're interested. So as I mentioned, we are actively looking for contributors and maintainers for our projects, and that includes Traefik and mesh. And you can find us on our community forums, GitHub, and you can also learn how to become an ambassador. And just to talk a little bit about that, ambassadors are recognized for their contributions to the community. That includes things like creating blog posts, tutorials, and being active contributors to the open source projects. So I will be sharing all these links in the chat and a link to this slide deck. And we are looking forward to learning more about how you're using Traefik and mesh, and learning a little bit more about you and meeting you. So with that, thank you very much, and we hope you all have a great rest of your afternoon. Thanks again.
Wow, awesome presentation, Kevin. Thank you very much. Perfect. Do we have on the line Kevin and his colleague, Manuel Zapp?
Yes, that is correct. Hi.
Hello, everyone.
Hello all. How's it going? Thank you very much. This talk was really great.
Thank you. I just want to mention to everybody the Win with Traefik link is going to be up for the next hour or two, so don't feel like you need to fill it out right away. We'd much rather answer your questions right now while we have the time. So don't feel like there's an immediate need to go sign up for that.
Perfect. Awesome. So we do have some questions, Kevin. The first one that we do have is like on a typical deployment, like of another service mesh, take example Istio, you often have to tweak for like CPU, memory, replicas count to ensure that you don't add any latency into your application. Is there any quick tips you can provide end users if ever they want to get on board with Maesh? Like any quick tips that they should know, like, oh, you should have at least X amount of replicas or increase CPU or memory, or are all the default values enough to get the ball kick started and have decent replies?
That's a good question, and it's one that comes up often anytime you start talking about adding new components and capabilities to your applications. And there's really no hard and fast rule, but the idea behind building mesh was to reduce the amount of overhead and latency that was introduced. That being said, there's always going to be some arbitrary number of microseconds, or in some cases milliseconds, depending on how many filters and rules that you're passing the traffic through, that's going to add latency to your applications. That's where having distributed tracing in place, as I showed in the demo, helps you understand what percentage of that transaction is having that latency latency added by utilizing something like a service mesh and the various different features and functionalities of it, because making routing decisions, applying regex, computing rules, it all adds overhead. And there's really no way to tell what that's going to look like beforehand, but it's just important to do a proof of concept, run some load tests, and just observe the results. So I hope that answers the question, but it just always depends on what you're trying to accomplish with it.
Perfect. Yeah, awesome. It summarizes it all. Excellent. I do have a question from one of the participants, and his question goes on: how does Mesh controls intra-nodes traffic? Some from the intrapod perspective. I know that you said that it doesn't use the sidecar container. It uses more like a daemon set deployment on each single node. But could you elaborate a bit more on this end, please?
I'll let Manuel weigh in on that one, because he probably could answer that question better than I can.
Perfect.
I can at least try to.
Okay.
All right. So for that question, generally speaking, Mesh will protect you for traffic leaving a node, as already said during the presentation, because as you already said as well, we are not running the sidecar proxy per pod, but rather as a daemon set. So traffic changing a node will be encrypted through like a sort of MTLS, let's say. So that is encrypted. As Kevin said at the beginning, our aim with Mesh is to be as simple as possible and like really non-invasive. For that reason, we assume currently, at least, that we won't, that we are not aiming to like protect traffic, like intranode traffic, because if an attacker gets access to listen on one of your nodes, it's already a pretty bad situation, let's say, right? So probably having that sort of traffic encrypted will, or might not be as efficient as the traffic leaving the node. Additionally, as Kevin said, the usage of Mesh is by changing the DNS name. So we are not enforcing IP table rewrites or any sort of that. So we have a distinguishing there, because we're not as invasive, so you could ever like find a way across the mesh, let's say, even without using our proxies. And so you could also do it on the same node. And for this, we're currently aiming to only protect the traffic leaving the node. But as Kevin said as well, we are trying to learn and then see how the community wants the design, right? If they were like, nah, we definitely need also on the node, we will be open for it. But like our current assumption is based on the feedback that we received, that it's going to be fine to focus on traffic leaving a node first.
Perfect. Thank you for answering, Manuel. I don't see any more questions. I might have one question that I will paste in the Q&A. So you guys, if you ever have a minute to go and answer it off afterwards. But I would like to thank you again just for making this awesome talk, showing, demoing other meshes that are now available. We're no longer having only one service mesh available. There's a numbers of service mesh available out there. Each one bring their own little advantages or differences in between. So it's really, I really like what you guys demonstrated today. Show the opportunities that there are with other service meshes and what it could bring to potentially other customers. So thanks again, guys, for this awesome talk.
All right. Thank you all.
Thank you.
Have a good day.